Okay, so it tells us between time 0 and 12, particle moves along the x-axis. The velocity is given by the trig function cosine of pi over 6t. The particle is at position x equals -2 at time equals 0. All right, part A, between time 0 and 12, when is the particle moving to the left? Yesterday, I mentioned you might want to just jot down really quickly. Moving to the left, velocity is negative. So to find out where velocity is negative, we need to start with where is it equal to 0. So cosine of pi over 6t is equal to 0. So we got to solve this trig function. This is inactive, so we got to know how to handle this. For the moment, remember, you forget what's inside the trig function. The question is, where is cosine equal to 0? Cosine is equal to 0 at pi over 2 and at 3 pi over 2. So we set that equal to what was inside the trig function, which was pi over 6 times t. We need to solve for the time, so multiply by the reciprocal, 6 over pi. The pi's cancel, 6 over 2 is 3. So that's how we go from having pi's and a trig function to we're talking about whole number times. So 1 time is 3. Do the same thing to the other equation, multiply by 6 over pi. The pi's cancel, 6 times 3 is 18. 18 divided by 2 is 9. Both of those are within our interval. So we're good to go. 3 and 9 are the places where it's equal to 0. You do get 1 point for considering that the velocity is equal to 0. So even if you're unsure of how to solve it from there, at least write this down. At least write that down. If you know that that's always your starting point, at least write it down even if you don't know how to solve it, because a lot of times you get a point for that. Okay, and then we actually need to figure out when it is negative, so we need our sign chart here. 0 and 12 are our endpoints, 3 and 9, so we need to check, I don't know, 1 and how about 6? Bless you. And trying to come up with easy numbers here that'll work out with the pi over 6. How about 10? All right, so if we plug in 1 into the velocity function, that's pi over 6 times 1, so it's the cosine of pi over 6. You don't need the actual value, you just need to know, is it positive, is it negative? Cosine of pi over 6 is positive. When you plug in 6, you've got pi over 6 times 6, so that's just pi. The cosine of pi is negative, or specifically -1, but we just need to know that it's negative. 10 over 6 reduces to 5 over 3, so 5 pi over 3 is in the fourth quadrant. Cosine is positive there as well. So the particle is moving to the left. For times 3 is less than t, which is less than 9. Don't include the 3 and 9 because those are the changing points. Just put less thans because v of t is less than 0 for these times. Again, it doesn't ask for a justification there, but it never hurts to go ahead and put it in sentence form just to make sure. Okay, part B, write but do not evaluate an integral expression that gives the total distance traveled by the particle from time equals 0 to time equals 6. So it is absolute value, absolutely. So it's the integral from 0 to 6. Make sure you pay attention to the times that they give you because it's not over the entire interval from 0 to 12. They just ask for 0 to 6. and it is the absolute value, and all you need to write is v of t. If you really want to put the cosine of pi over 6t in there, you can, but it is completely acceptable just to put the v of t because the function was labeled as such in the problem. There's no point in writing it out. So just a 1 point part there, kind of unusual, but it does happen sometimes. All right, part C, find the acceleration of the particle at time t. So that means in general terms. So acceleration is the derivative of velocity. The derivative of cosine is negative sine, and you have to multiply by the derivative of the angle. So it's got a pi over 6 in front. And you keep the angle the same inside. So that's part 1. Don't ignore, be careful when they start with just sentences like that, because a lot of times that's a point in the question. If you're not reading carefully, you'll miss a point there. Okay, is the speed of the particle increasing, decreasing, or neither at time equals 4? Okay, so we already know the sign of velocity at 4. Velocity is negative, so now it's just a question of what is acceleration at time 4. So acceleration at time 4, it starts by multiplying by negative. So the question is the value of sine positive or negative? So 4 pi over 6, 4 pi over 6 is really 2 pi over 3. 2 pi over 3 is in the second quadrant. So really, you don't have to know the value here, okay? It's great if you do, but really you just need to know, well, is that positive or is that negative? Sine is the y value, so it's positive in the second quadrant. So we've got a positive number times that negative pi over 6, so your acceleration is less than 0 at time 4. Our velocity is also less than 0 at time 4. So since velocity and acceleration have the same signs, at t equals 4, the speed, make sure you say the speed. Don't just say the particle, say the speed of the particle is increasing because they're the same. Okay. I try to avoid saying because they're both negative or because they're both positive. Just say that they have the same signs or they have opposite signs. That's the more correct way to phrase that explanation, as opposed to say that because they're both negative or because they're both positive. Okay, you're almost saying that it has to be one way or the other if they're not. So. Okay, part D, find the position of the particle at time 4. So position of the particle S of 4 is equal to, what did we start with? We started at -2. What time was that? That was time 0 at time 4 of our velocity function. Now, normally, if this was calculator inactive, I would just write v of t here, but I'm actually going to have to integrate, so I might as well put the function there so that I can see it. All right, so if we anti-differentiate that, the antiderivative of cosine is positive sine. Technically, this is a u substitution problem because it wasn't just the sine of t or the cosine of t. But let's think about it this way, so we don't get hung up in the u substitution. If we take the derivative of this expression right here, derivative of sine is cosine, so we've got that part of it. But we're going to have to multiply by the derivative of the inside. The derivative of the inside is pi over 6. We don't have pi over 6 in front of the cosine, so we have to have the reciprocal of that in front. We need to have 6 over pi in front. so that it multiplies out with the derivative of the angle. And we're evaluating that from 0 to 4. Now, I would put that 6 over pi, I would just put it in front. So we've got the sine of, plug in 4, so that's 2 pi over 3 minus the sine of 0. The sine of 0 is 0, so we don't have to worry about that one. The sine of 2 pi over 3, we didn't work it out in the previous problem, but we do need it here. So the sine of 2 pi over 3 would be the square root of 3 over 2. So if we kind of neaten that up a little bit, you don't have to do a ton of simplifying. The way that I understand it, this answer right here is fully acceptable, but I don't know about you, that I don't like the way it looks. 6 over 2 is 3, so that would be 3 square roots of 3 over pi. I still don't really like the way that looks, but there's not really anything that we can do about that pi in the denominator. It's just there. I would not try and get a common denominator. Don't get crazy with the simplifying, because you really don't have to simplify it a lot. But I do like to take it to that step right there. I would not, I boxed it just so that y'all knew what I was talking about. The way that I've read some information recently, I would just avoid boxing in any answers whatsoever. Don't box them in, okay? Do not box them in. Even if you feel like you need to, just don't. Leave your work there. Let the reader read what you have. Okay, they're supposed to look at everything that's there. So just don't box everything in. I just did it for emphasis.